Hey, welcome back to Made Up of Wires, where we decompile Castlevania Symphony of the Night, among other things. Mostly decompiling. If you're not familiar with the project, go to soten.z.dev to learn more. I don't say it enough, but I'm a contributor to the project. It's not my project. This project was started several years ago by Zianamo, and just huge shout out for creating a great community. I want to say thanks for everything you've done. We couldn't do this without all the work that you put in. So appreciate you. You'll find a link to the GitHub source code and a link to Discord. I said it many times, but one of the things that I think is like a huge strength of this project compared to some of the other projects that I've looked at and considered working on is the amount of tools and the general desire for quality. So tools for where I started extracting files from the disk, tools for linting and rewriting code to be consistent that are custom for this project, finding duplicates. There's a ton of I think really amazing things that people decided to spend time to get right to make life easier for everybody else who works on the project. And so it's not just one person who knows everything. We can all build on the tools. Hey Gabe, good to have you back. It's going well. It's going well. Yeah, who makes life easier? And I mean, those are really force multipliers for decompiling. It used to be that an overlay would take a month, and now we can do it much faster. Sometimes they do. Sometimes you run into something new that hasn't happened before, but for the most part, we've seen what there is to see. I'm gonna go over something that I've been working on recently. And it's related, but not quite the same as like getting into the overlay stuff. So we're compiling against a very specific version of the PlayStation SDK, and finding specific versions of the PlayStation SDK physically is effectively impossible. Finding them otherwise, there might be a certain archive online that has a bunch of these, but we're able to look at different things that were defined in the 3.5 SDK, which is what Soten was built against, and see different inline macros and other headers that have definitions. One of the things that I was looking at recently was the rotation average 3 function. And right now we have this marked in Splat as being an assembly function. And let's see. So we have all these GTE functions. They're marked as assembly. And what that means is don't try to decompile them. Just dump them out as assembly. And then when compiling the project, they get compiled back in. What's kind of a bummer about that is that means we don't get any C-like source code, which means that it's much more difficult to change, patch, or maybe port to other platforms. And so I wanted to look into that and see if that was really a restriction. Were these functions really written in assembly, or is it just something that maybe we didn't want to worry about, and so it's kind of a legacy decision, and we should go back and see what we can do. And I think it's a mix of both. So, like I said, I wanted to look at rotate average 3, and I found where that was, and I was able to come up with something relatively C-like, and using, with the exception of this DP flag, using macros that look a lot like the macros that were shipped in the 3.5 SDK. What do those look like? Not so much this file, but let's look at another one. So they're in an inline C. And so one of the first ones we need is this GTE LDV3. What does that do? It loads values into the GTE, or it calls coprocessor commands that load values into the GTE register. And I'm not super familiar with the GTE coprocessor yet, working on it. But my general impression is it has a handful of registers that you can write data to. They're mostly 32-bit registers. So you load data in specific places, and then you call a function, or you use a command called C2, which basically tells the coprocessor to do something. And in this case, we want to rotate. So we're going to call GTE RPT. And there's not even instructions that the assembler that Sony shipped would generate. So we're just going to put a binary in. And what's interesting is the SDK libraries themselves do not use these particular binary values to generate this instruction. And we found some of those, and we have the corrected versions that we've been using. But this is what, as a developer, PlayStation developer, this is what you would have used to call the rotate around a point function in GTE. What Sony used was quite a bit different. I'm not sure if there's anything important there, but this is the word that you write. It's not even the same like top bits. It's really bizarre. These were found through experimentation a long time before I got here. So anyway, you call these things, and if you look at the documentation for the rotate average 3 function, it says that this would be a lot like a macro. And where is that macro? Called GTE rotate average 3. And it'll be in here somewhere. Let's look at this one. And what this does is calls a bunch of these other, or inlines a bunch of these other macros, which are inline assembly. And so we can see the general structure of this, which is pretty helpful. And you can imagine if you were writing a compatibility layer, having something like this would be pretty nice, because you see that we're loading these values into the coprocessor registers. We're calling the GTE function to do this thing. Then we're loading these other, or getting the values back, storing them into these pointers passed in, storing the, what do you call this? There's some register that has values. I can't remember the name. There's a flags register. And then I can't remember what AVS S3 does. It's another function to call the coprocessor, or tell the coprocessor to do something. And an OTZ is the return value. So reading the return value back. And so we have a pretty nice C-looking version of all these macros together. The problem is, if we would plug this into that function and use it as the implementation of the function, it does not generate the same code as what Sony actually shipped. And there's a couple reasons for that. Sony wanted to ship in their libraries relatively optimized code. And when you put these things together, the compiler and other things like that, there is going to make decisions that maybe you wouldn't make if you knew how to optimize for a specific processor very discreetly. And part of that is delay slots, the time it takes for reads from memory to come back. And so we can do a few things, and what I did, the main thing that I did to get this working over here was, instead of having separate pseudo functions for getting the DP register and the flags register, I put those together. And the major point to all this is, if we look at how DP was originally written, I'll try to reorganize this. It calls this CFC2, which is writing some data to the GTE coprocessor, and then it has to do a NOP because it can't read the result in the next instruction. It takes one more instruction to be able to read the result. And then we can call this store word function, which is doing something slightly different. But the point is, we have at least one extra cycle than necessary if we don't know how this is working. And if we reorder these instructions, we can get rid of that NOP, and that ultimately will make our implementation faster. There's a bunch more to it than that. There's a bunch of cases up here where we know the position of various arguments, either in registers or on the stack. We don't need GCC to come in and put them in a well-known place, because the ABI is very strict and we know what the compiler is going to do. We can kind of assume certain things. Is GTE the GPU? Yes. Graphics transform engine. It was a hell of a drug. Yeah. This wasn't Konami. This was Sony. So this is all Sony, and the examples that Sony gave would always give you a suboptimal implementation of this, which is why they gave you a C function to call. In 1995 and 96, it was still a time where you could write assembly better than the compiler. It was probably not till 2000, early 2000s that I would say that switched over. When pipelining became a thing and compilers, I mean, there's the really terrible example of Itanium, where the compiler had to be smarter than a human because nobody could actually program for the thing, and then it never did become smarter than a human, so it never ran as fast as they assumed. So Eldridge is saying they have to do a lot of shuffling of registers and memory moves when they have to do more complicated things. I can't imagine writing ASM for a mod and trying to get it to fit in. That just seems bonkers to me, and what you guys do is bonkers. I would imagine there's things in C that I know that could be optimized in the game in general. Now that we have a lot of the C, we could go through and rewrite and make a hyper-optimized PlayStation version. Even just bumping up the optimization level would probably produce something a little faster, and that'd be fun maybe to try an optimized version of the game and see if it breaks. But it is interesting to see that Sony went the extra step and did hand tune a lot of these things, at least in the GTE space. Anyway, that's what I've been looking at lately. What I think I'm going to propose, kind of a bunch of like side projects from Soten Decomp, is getting a decomp of the PlayStation SDK, specifically the versions that are relevant to us. And so I'm going to propose that we do something like this, because so why do you want an SDK decomp? Kind of what I hinted at before. If you were going to make a platform independent version of this game, there's a couple reasons actually. The PSP has this in it. We don't know what it looks like yet. We've looked at it a little bit on the stream. but we know that there is a re-implementation of a lot of these functions. A lot of them are stubs, but they exist in the PSP version of the game. They probably exist in the Xbox 360 version of the game as well. And so one day maybe we'll look at that and see. The PsyQ SDK, interestingly enough, I was reading more about it. So it was written by Psygnosis. They kind of took it. Sony decided that they were going to work with them. Maybe they bought them around that time. But PsyQ exists for the Saturn as well. And so I haven't looked at any of the Saturn stuff at all. But it would be interesting to see if this is what was used for the Saturn port as well. I don't know as much of the history around the Saturn version of PsyQ. Sometime around 1999, it was renamed to the PSX SDK, I think. And they took the PsyQ name away. Anyway, so that's Rotate Average 3. It's a SDK function for GTE. Right now we have it marked as assembly. I'm trying to make it look like C. If we created a compatibility library for portability, implementing these functions is much easier than implementing Rotate Average 3. It does tie you to the architecture of GTE a little bit, but that might be okay. Okay, done with that. Let's get back to Richter. Yes, so the PsyQ SDK decomp is a there's two of them that I know of. This is the one by Sozu D, and I contribute back to this when I can. Hey, there's me. So I don't focus a lot on this though, because on the stream I think most people are interested in Symphony of the Night. But if people want to see PlayStation SDK, I'm happy to look at that as well. When I get matches, I will try them. The way that this project is set up is a little harder for me to to get into like a development loop where I can try things, and then if they break, fix, and kind of incrementally get to a match. So Xianimo, who started the Soten decomp, he also has a PsyQ Ship of Theseus style decomp of PsyQ. I haven't looked at that one as much, but everything we're doing for PsyQ decomp is more liberally licensed, so I think we'll get there eventually. All right, so let's get back to Richter. So we've been working on Richter, and I was going to say something about Shaft's orb, and then it reminded me that my wife thinks that the SNL skit with sweaty balls is funny, and that kind of reminds me of Shaft's orb. And so we're going to keep looking for Shaft's orb and see if we can find it. So let's see where we are. Oh, wrong directory. I'm trying to, I'm considering how far I want to go with it. I am somewhat interested in doing a PlayStation test. So there's like the 240p test suite, if you're familiar with that. But basically building a test suite for the PlayStation SDK, a publicly available test suite. I need to remember where everything is. Oh, I did add some more splits here, so this might be in a slightly different place than the last time I looked for it. Oh, I need to find entities. That's why I've been looking at the SDK as well. I think this is the one we want. So last week, yeah, we found the shaft entity. One of these two, I think, is going to be the orb. So let's see if I can find that. And I need both those things. I'm going to grab this command. Sorry. I'm over here. Not showing the right terminal, or right window. So we want this A38 function. Do we do that one? Maybe we did that one. Or the FE8 function. So we have FE8. Let's see what it is. Appreciate this, Eldritch. Oh, this is nice. Oh, this is good too. So we have a table like this, but we don't always have the definitions. So let's look at what these are. Do Sword Lord. Oh, come on. All Night. Where is this? It's in config. So there are places here where we just have values, and it would be much nicer if we had enums or macros. So we can see, in this case, Sword Lord 61, 12, 33. 61 is HP value, attack value 12. That probably isn't the right place. And then attack element, we should have a enum for that. So 33 is the attack element. Let's look at enemy def. This is actually super helpful, and maybe I'll look into this tonight. Yeah, so we know it's an attack element, but we don't have an enum for it. We do have an enum. Something like 33 though is a little odd. Oh no, 20 hit. Unknown 10. There's an unknown 2 in there then. Okay. Hitbox state, I don't know if we have an enum for that. These would be good as well. These are probably the same elemental weaknesses. Oh, and the rare IDs, that would be nice as well. Anyway, I think getting named values in there would be super helpful. Oh, you stole the tables and made them... Well, then you don't mind if I steal your legibility and put them back. Into our... steal it back, yeah. Alright, so let's see if this is the orb. So, I didn't go... I should have done this. I should have created a save where I had all the right stuff to see the orb. I talked about it on Thursday and then didn't do it. Reverse. I heard you like reverse engineering, so I reversed your reversing. So you could reverse while you reverse. That's how we make progress. All right. So a few things. Get free entity, get factory. My guess is we are not going to need those. So we have one global to worry about that we don't know what it is. Oh, sorry. Let me, oh no, where's my switch? Too many tabs, always too many tabs. All right, so this is how we started. We have two function signatures, declarations at the top. We're gonna get rid of those. Usually they're not needed, and the only thing they're doing is standing in my way. I don't need the types usually, especially for the PlayStation version. So we have one global that we don't know about. It may be part of the player struct for Richter, so we should figure that out. Let's go grab that address. I'm glad that there is kind of this cyclical relationship, and that we can, the things that we're learning can help you guys, and obviously a lot of the work that you've all done has benefited us as well. Let's look for G-Rick. Its size is 3DO. I think that is after this. It looks like it. So let's look for anything else in the 181E9C range. 801.819. So we don't really have anything near there. So let's look up that. Oh, B06. So it looks like bytes, just a table of bytes. We don't know what it is yet. My guess is that they're pairs of bytes based on the +1 here, and then I'm guessing there's going to be a +2 at some point, but maybe not. Maybe it's just the first two values. We'll see. We'll call them bytes now, though. I'm going to make them unsigned until I know different. Yeah, I think it would be worth going through some of the randomizer stuff. I've gone through, it was maybe a year ago, and looked through it, but I probably need to go through again. So I'm going to go through and start cleaning up temporary variables, anything that is V0. I want to get rid of V1 also. And then the S variables on the PlayStation, they're less likely to be true variables. On the PSP version, they often are true variables. Oh, we have unknown 30. This is strange. Oh, yeah, Yeah, we have no member name unknown 30. Let's figure out what that is. We know this is an entity. So we should be able to figure out what this is. 30 is params. I don't know why M2C didn't know that. 10 past 0 we're going to call params then. This may or may not be yeah. So often params is a 16-bit value that entities can use to store their own flags or other data. And how it's used is very dependent on the entity. And so often we see masking here. It looks like it's just some numeric value that ends up getting multiplied by 2. Rename arg0 self. Oh, the browser is covering my face. Thank you. I must have resized it at some point. Hey, I like Excel. I like tables. Nothing wrong with that. Before I go too much further, I really should get this compiling. That'd be helpful, right? All right. So when we do pointer arithmetic, often that's the same as indexing into this array. And we got something that compiles. All right. So I'm going to try to get rid of the go-tos. When there's a go-to to a block that's in the default, typically that means this actually is outside of the switch. And everything that's going to that is going to break, including where I just move this. And GCC is going to do its own thing. And then we can get rid of that. All right. So we have another set of go-tos. Those are incrementing the step, and then they're breaking. So I just have to make sure that if I replace it like this, that the next thing that's going to happen is that there's a break. And there are some cases where the go-to didn't get generated for reasons. Only one of them. Oh, GCC, you're so silly. Temp v0 we're going to call prim index. The index into the primitive table. Temp A. Oh, this is interesting. This did end up being a pointer. We'll look at that in a little bit. I'm going to go down and see. So whether this is actually prim index or it's just assigned directly, it's hard to know unless we grab the PSP version. I'm going to assign it directly and get rid of the variable. then kind of work down. What I want to see is, for these temps, would it make sense to put this inline, or does that not make sense? Some of the other things I'm going to look at are if we're assigning fields that are numbered. So a primitive, let's rename this. Primitives we typically call prim. So if prims have 4 sets of coordinates, prims have 4 sets of location coordinates for their quads, but then also 4 sets of texture coordinates. And so if we see those listed out of order, usually that means, and they're being assigned to the same thing, usually it's like a chained assignment like this. And then we also have the ability of getting rid of that temporary variable. So I'm going to go through and clean that up. And as I go, just keep checking whether or not something, if anything else makes sense to get rid of. Or move. Keeping those together probably makes sense. And so I'm just going to reorganize this and try to get to something that looks about right. If it looks close to being right, it often is right. Because you have to assume that the people who wrote this originally were reasonable people. Sometimes that's true. Yeah, so these do look like XY coordinates. Drat. Can't quite get rid of them. So I think we'll do a pos X and pos Y variable. Or this could be acceleration X and acceleration Y. It definitely is possible that those are being done inline and being optimized out, but again, we don't know. We won't know until, I think prim index I ended up getting rid of. We won't know until we pull the PSP version. Definitely thank you for stopping by, Eldridge. It's always a pleasure. Down here we have a timer. It's pretty common for timers to be at the first field in the entity extension union or struct. That's part of the extension union. It's not a fixed and hard rule. It's just very common. So I'm going to start. I think that this is a unique thing. I don't think that my guess is that this is the orb, and so what we're going to see eventually is, and probably what this is, yeah, and down here as well, the orb kind of moves around. Let me see if I can find a video, since I don't have this queued up. So if you do everything right, you're going to go fight Richter. We'll get through this. And yeah, so you see Chef's orb up there. It's kind of going around. There's some randomness to its movement. But generally it's following a sign-like pattern. Oh, and that's interesting. So the shower of the explosion that came out afterwards, that is the other function that we did last week as well. So we have Shaft, who has his nice "I am Shaft" text that tells us exactly what that entity is. And do we see Shaft? No, we don't see Shaft until the orb is broken. So there may be some additional complexity around like the texture behind the orb. It's a little wispy trail. But then we have the explosion, and then Shaft shows up. He's translucent. So that's what we're working on. I'm almost positive this is the orb. So we'll keep going through this. We're only allocating a single primitive that is the orb. There may be another function that is responsible for the trails of the orb. I'm not sure. But I'm going to keep doing the same thing. I always say this, but I'm going to say it again for anybody who is just tuning in and maybe doesn't follow. The number up here, as it gets closer to 100%, which is ultimately what the goal is, may fluctuate going up or down as I make changes. I'm not terribly concerned because the code that we get out of M2C when it's decompiled is so wrong. So wrong. It's not always wrong, but it just has a lot of noise in it that has to go away. So what noise are we going to work on next? There are a bunch of variables in here that are worth getting rid of. I'm going to call this, we'll work on variables a little bit more, and then I'm going to start with the entity extension because I think this is going to be a unique one. I'm going to call this entity. So this probably is the getting destroyed case. And we have more timer stuff there. We have a plus equals. I'm going to see if this ends up working out. If I do a plus equals there, and then, yes, this will work out. That should be fine. And down here we have a bunch of the same type of thing. We're just going to make as many of those inline as possible. And these should clean up pretty nicely. I think that these are being pulled out into a temporary variable, but I don't think that temporary variable exists. I think it's just being done inline, and then the optimizer is just caching the value. And possibly not. This part looks fine, but we do have some code that's getting generated at the end that looks quite a bit different. So there might be something else going on down there. We'll see. It definitely is possible that these are calculated beforehand. So let's try it. Let's grab a sine 32 pos x and sine 32 pos y. It's surprising, I think, what the optimizer decides to do and what it doesn't. Some of it comes down to aliasing. Can you guarantee that this prim pointer isn't overwriting either of these two values? If you can't, then you can't cache those reads, even though we know that they're not the same. The compiler can't know that unless it can. And if the compiler can know that, then it will cache them. Okay, this, yeah, worked out this way. Hey, Disick, good to have you. Appreciate you showing up. All right, so a bunch of register issues, but mostly looking pretty good. Let's work on this case. So like I said, this is gonna be an entity extension. We're gonna need a new one. I always find entity extensions a little error prone, but I think this one will be fine. Do we prefix all these with ET now? I guess that makes sense. So in our initial offset, which is at offset 7C for the whole entity struct, we're going to have a timer. And all of the ext illegal U16 zeros are going to be that timer. I'm assuming that this is a signed 16, but it might not be. It might be an unsigned. No time but the present. It's like it's saying he's a little late. Never late. Because we're just having fun. All right. So this is pretty common. Prefixed decrement, not operator, so we're not doing a direct comparison against an integer. We have this temp sine 16. My guess is that this is the so it's the velocity angle. So like we could call that a velocity vector, right? Velocity angle. And I do want to pay attention to what is happening. I would like to pass this directly to these functions, but if it changes how this compiles, then I won't do that. We run into the same issue. Do we know that cosine and sine are not going to mutate this value? We don't have any guarantees of that. So will GCC... Yeah, it does the load again. So it doesn't know if our cosine changed this value. So since we're referencing it as a field in a pointer, we don't know if that changed or not. These aren't really things that we usually think of anymore, but they were bigger considerations in the 90s. And so you know as a programmer that if I store this in a local variable, that fetch isn't going to happen again, and that might give you some performance boost. These, I'm assuming, are inline. And that got that part straightened out. We have one additional thing that's on 82. So we have an instruction that's loading the timer down here. We have basically the same construct, so I'm going to move that, rewrite it that way. GCC does this interesting shift thing. I think that has to do with it being a 16-bit signed value, and not trusting that the way that it's stored in the register is 16 bits, so it shifts it over so that the top bit will represent the sign, but that happens automatically. So we don't need a separate variable for that, and that straightens that up. I'm going to move velocity y down. I don't think it'll change anything. This is one of those cases where, by not changing anything, I mean I'll change everything. This is one of those cases where GCC should be able to know that these are not aliased with each other. Crazy. Every time y is assigned before x, I assume it's incorrect. Especially in this case where the timer assignment doesn't matter. I guess we have a situation here where rand could change the value of x. So again, it's kind of like a guard. Anytime we have a situation where the pointer could be aliased or mutated outside of the context of this function, we have to maintain ordering. The shift left could be a multiply by 32. Yeah, possibly. Is there a reason we would want to shift left instead of multiply by 32? I don't think so in this case. Likewise, this could be a multiply by 4. But it's not. This happens a lot as well. We take a timer, we look at the bottom 2 bits, and if they're one way or another, we're going to do something. I think this is where we're pulling in the smoke, maybe? And we're grabbing it looks like a pointer, but we don't know yet. So we're saying whatever this child entity is, point to the same thing that I'm pointing to. My guess is that this is pointing back to either the Richter boss or something else, but I'm guessing it's a pointer. So I'm going to call this parent. And let's double check where that was. So it's 16 bytes in. We have 4 bytes already. So that's our 3rd byte, 4th byte. this is an assumption. And we know that the other one isn't parent, or isn't an orb. I will have to write a assertion for this as well, but that will come later. I'm gonna write myself a to-do. I think this was, I don't know. We'll see. We'll see what. Is there a percentage completion somewhere? We don't have a total percent completion. Oh, shift right divided by 2. Of course. Thank you. I can math sometimes. Yep, that works. Oh, no, it doesn't work. I screwed something else up. Oh, what did I move, or what did I do? Screwed up my struct. Okay, chat. Where's my mistake? No semicolon at end of struct or union. Oh, I know. We don't have, because this struct is part of the union, that is the ext field of the entity struct, we don't yet have a type def. This, we could have this, and it would totally work, but we don't. We could pre-declare that relationship. We don't have that, though. And the divide by 2, when you do an actual divide, or sorry, divide by 4. When you do an actual divide, GCC wants to put all kinds of error handling and things like that in there, and we don't have time for that. Yeah, thank you, Dizek. Appreciate it. Thank you, Roaming, as well. Appreciate it. I've made this change in the past, and I should submit it again. Last time I mixed it with too many other things, but there shouldn't be any reason, right? So I pre-declare struct entity. There shouldn't be any reason I can't pre-declare the type def too. And then I don't need it here. And that works just fine. And then I can get rid of all these, I shouldn't need it here anymore, right? Oh, I do! Well, forget what I said. Ignore the last 2 minutes. I think that should work. Slightly disappointed it doesn't. Oh, we have some fields that are slightly wrong here. I think I am off by 4. So let's throw another one in there. And now we just have registers. There's, I guess, one instruction up here on 49. Okay, and this is suggesting that this is having inline, or let's try that. Nope, Or, oh, these are pairs. These are pairs. This is an array of pairs. That's what this is telling us. So temp A1 and 2 are pointers to pair arrays. I don't know if we have, that's what I wanted. That's fine. Oh, this is kind of gross. This is kind of gross. So the way that these are done is not quite the same. We're subtracting 2, which means we want temp A minus 2 and plus 2. I'm going to see if I can emulate that without the variable. So it's temp A minus 1. And temp A plus 1. But it doesn't like that either. So let's make temp A a pointer to unsignate 2s. And then this would be minus 1 and plus 1. I don't know if I like that any better. Can I ask, have I worked on other games? No. No. I've done a bunch of reverse engineering for Sega CD stuff, just like kind of personal on my own time. Nothing that I ever made public though. I want a pair of bytes type def. Something like U8X. S8X. I feel like we have this somewhere. Yeah, and I've lurked around other decomp stuff, but never did anything about it. What would a UV pair? How about that? I like UV pair. So then temp A1 becomes a UV pair pointer. Up pair, not I need UV. So this is going to be UV pair minus 1. We could do the same thing. F.x and pair +1 dot x. Pointer. Oh, of course, it's not. It's you. And so down here, we shouldn't need a second read from that array. We should just be able to go to V. So let's see if that... Same thing here. I'm wondering if I got this wrong. But let's do the same thing, UV pair. We could do it as a subscript as well. This doesn't feel right. Oh, and it's temp A1. I think this is wrong. I think I'm going to pull the PSP version. Get rid of the compiler warning. Let me look quickly back at the okay, so possibly we have two variables. And we keep flipping between them. I'm going to pull the PSP version, though, and see. Actually, if I throw these... let's get rid of Rick's Z priority. That fixes that a bit. But we're looking worse. I'm going to throw these into the context. Get a fresh decomp, and see what M2C would have generated for these. Yeah, so it is grabbing a pointer to the second field in that UV pair. I don't like that. I think that is probably a GCC optimization, but how? I'm not quite sure yet. So I'm going to grab the PSP version and it's going to tell us. So how do we find the PSP version of this one? We need a magic number, and there's not very many magic numbers here. We have a bunch of calls to rand, 4 of them, and artan, atan. I think that's probably our best. The COO is pretty good too. So let's look for... Let's look for the COO first, because that velocity will stay the same before different game versions, I'm pretty sure. Quite a few that showed up, so we want to take those, and we're going to look for ones that have rand in them, fewer, ones that have atan, fewer, ones that also have cosine, same. Sign. Same. Okay, so we're down to 2 functions. Let's find a new magic number. 43. Let's try that. There's also 4a. I think that's it. And we'll look at this quickly just to see if we can confirm or deny. We have the read of 30, offset 30 in the argument to the function, which is the params field, and then 2c, which is the step field, and we know that those 2 things are happening right away. Params and then step. That's not a smoking gun, but it's pretty good. What else? We have our this number is interesting. So it's 1080 shifted by 16. Do we have anything like that? Yes. Okay. I dig it. That should have been my magic number. Can I feel free to ask any questions along the way? I'm happy to answer. I wouldn't say that I'm an expert in decompilation, MIPS, PlayStation, SOTN, or anything else I talk about, but happy to opine on any topic related. I may or may not be the most qualified streamer to talk about this, but probably not even that, even though I don't know of any others. We have to do a few things to get the PSP version working. Yeah, the Prim GT, yeah, possibly. How we, so that argument to the allocate primitives function. All right, so we need to add our new entity extension in. So that wouldn't be in this context yet. The other thing we have to do is modify what the primitive structure or the GT4 structure looks like. Because everything is shifted by 4 bytes on the PSP. And my theory about that, and maybe there's somebody else who has already determined this. So when the game was ported to the Xbox 360, pointers needed to be 64 bits. And we'll just throw an empty one in there. So we have this pointer right at the beginning of primitive. Everything is shifted by another 4 bytes on the PSP, and so to get things to align, we have to put that there. The other thing I want to do, I don't want to go to that tab, I want to stay here. I want to throw these all into the PSP context as well, and then have a relatively clean version of M2C's output here. But this should be pretty good. And what we should see, and this is not what I expected, but actually is pretty interesting. Oh, not what I expected at all. So we're using this UV pair pointer. And then we're doing I think it's just, we would think of it as UV pairs, but I think they're just treating it as an array of 8-bit values and doing the offsets manually. That's not what I like to see. I like it when it's structured, but I don't think that's what's happening. And the reason I don't think that's what's happening is because the PSP is pretty good at having the right order of these operations. and we're adding the +1 kind of in the middle of all this. So I think our indexes are just computed kind of on the fly. Let's try it and see. We also don't have a variable for it, which is nice. So we can get rid of that. We're going to do temp A0 times 2 minus 2. And then down here, temp A0 plus 2. I'm not compiling. No, because of probably this line on 49. I'll take the warning about uninitialized. So let's look at that. Sorry. Watching the whole process is relaxing. It's relaxing for me too. Sometimes there's a bit of stress. It's just the right amount of stress. I've said before that this is my Sudoku. I think it's a fun thing to do. How much has been decompilation? Why does it take so long? It's been 5 years and halfway through it. So I was thinking about this morning. So there was a relatively small group of people working on it up until about a year ago, and then there was some more interest, and so the number of people working on it has increased, maybe doubled in the last year. So that was one thing. About a year ago, we didn't have a single overlay finished. But sometime almost exactly a year ago, we had an overlay 100% decompiled. And that's a pretty huge milestone to get something that you have the complete source code for. You don't need to rely on anything but like assets from the game disk. And we didn't have any overlays, and now there are many, and we go back and look at the status. All these 100%, we have 100% code for, and it's about 40% so far. I know me and Project Oblivion and some others, actually Zynamo, Biz Murphy, spent a relatively significant amount of time working on tools for, and SozuD before us, kind of consolidating tools for deduping to make it easier to add new overlays. So I would say anywhere between 60 to 80% of any of these files is duplicated code. And we just didn't have tools to easily recognize where that code was in each overlay and kind of do the work of deduping that for people. And now we do. We have much better tools for that. So early on, things are going to go slow, I think, with any decompilation project. You need to learn what the general structure of the game is. Any of these, basically, this entire file is 5,000 lines of structs, enums, function signatures, etc., that somebody had to go through and figure out. And now that somebody has figured these out, we can go much faster. But getting to the point where you can go fast takes a while. All right, I'm gonna try the rest of these. I'm not sure that I like where this is going. I don't think I'm going to get the +1 -2. I think even MetroWorks won't not optimize that. I can try with parentheses, maybe that'll work. Temp A0, wrong. I chose the wrong thing. This is params. All right, so what do we see? So we're missing a sign extension, and I'm a little surprised. We don't have the right thing here. So this is going to be a sign 16. That should do the right thing for us there. The subtraction of 2 is happening later than, or earlier than it should, which makes me think that it's almost like we're taking a reference to this. And this isn't how I would write this, but I'm just trying to get it to compile to the right thing. And then subtracting, but that's definitely not right. Maybe it's simpler than I'm thinking. We're loading the array and then subtracting 2. Oh, this is so stupid. This is so stupid. I'm dumb. It's fun having light bulb moments and getting something to, like, basically seeing this is way simpler than I thought it was going to be. Ordering issues. I think these are probably happening. Oh, these I pulled out into variables because I didn't think it was working this way, and here we see the same thing. So we're going to have grams times 2, and then subtracting 16. Let's try to keep them in a variable. And the other one is going to be grams times 2 minus 1. So register issues, but that's okay. My guess is I have a pos X and pos Y. My guess is that those are going to end up being the same. The subtract 40 is coming last. It's possible that there is no variable here. And the 1080 is happening after. So this isn't quite right yet. This looks better. This is going to be assigned 16. So we're finding the tangent, which I think basically that's going to be given an x and a y. Like, what is our distance? Plus some random value. Do we use this anywhere else? Did I give it a name? I gave it a name. Velocity angle. That's kind of just the velocity. I don't know if angle is necessary. Again, we have some registers that are mismatched. There might be an assignment in here. The S3. Yeah, there is. There is. So let's. Oh, I have velocity angle. I like the name velocity better. All right, that's looking pretty good. 63. We get an additional sign extension, which I wasn't expecting. The sign extension basically is taking a 16-bit value, converting it to a 32-bit value. So if the top bit of that 16 bits is set, we need to propagate that all the way over to the top bit of a 32-bit number, filling in ones along the way if it's 1 and zeros if it's 0. We don't get that if it's a straight assignment. So I'm going to turn it into an assignment. Yeah, signed text can be painful. Agreed. So we have a few more of those here. 73. This seems... The variable is assigned 32. So now we can go back here and we'll only get the sign extension once. That is what I was missing. And yep. And we're getting closer. The S8 versus S3 suggests that one of these variables might be reused. I'm not going to worry about that yet. I'm going to go through everything else. Fix that up. This should, I'm guessing, maybe, that this matches on the PlayStation. Or, oh, not the context. Don't get rid of the whole context. Or at least is close. And by matching, I mean doesn't compile at all. You know, well, they're basically the same thing, right? So yeah, pretty close. We have a byte versus a half. And this is going to be a difference between the two versions. So originally I had this as a byte. This is even treating it as unsigned, which might be better, even on the PSP. And that's right. Yeah, so I think this is a bug fix. So we'll if-def that for the PSP. Rams usually is unsigned 16. I'm going to try unsigned 16. So my guess is that this overflowed at some point and somebody realized it, or they got a type warning. And the sign 16 is right. No. It is being loaded as a byte. Unsigned byte? Is that true? We don't have a load byte. We have load half. Word. I don't know, a byte. Have we not needed this in the past? So params is a 16-bit value. So let's do this. Let's mask it. Okay, that's all that was necessary. Let's try that on the PlayStation. Maybe it is correct, and the PlayStation is just GCC is a little smarter than MetroWorks in the mode that it uses. Yep, that works there too. All right, so going down. All this is looking very good. We run into some register issues. I think I've the acceleration X and Y and pause X and Y. I think those are going to be the same variable. I think that's going to be the issue. Let's try that. It's a pretty easy thing to swap in. They don't end up matching. And my stack gets too small then. So maybe there's something else. And it's possible that they're just the order of assignment or order of declaration is different too. 71, there is a sign extension. I do this a bunch. How these are written. So if I say not this value, and then or write equal to 0 that value, those are the same thing. Logically, they're the same. MetroWorks generates different code. It does the sign extension of the 16-bit value to compare it against the 32-bit value. That doesn't happen on GCC. Oh, screen froze. Bummer. Well, that's it. Everything works. Saw it here first. I'll fix it. There we go. I'll back that out. So timers typically are written like this. You pre-decrement. So the decrement happens before the not. So if it's anything other than 0, the not is going to make it false. Otherwise, it's going to make it true. But the PSP tells us there's a sign extension there. The way that we can get the sign extension is by making that an explicit check against 0. And MetroWorks makes sure that the work is done to convert this 16-bit value into a 32-bit value. It's the same. Generates this. The logic is going to be the same. It's going to execute the same way, but obviously the code gen is different. Same thing down here on 83. Those are tricky the first time you run into them, but then they become not tricky when you see them a lot. 86, we're pulling this out into a variable. Or not. I'm going to try, instead of shifting, yeah. Again, like when you do the shift equals operator, MetroWorks is taking a shortcut with what it needs to do. When you write it like this, the compiler comes in and says, I need a load here. I need to shift the value from that load, and then I need to store. Whereas there must be a different code gen path for this, where it optimizes out the extra load. '92, same thing. I think. Maybe not. Let's try this. Let's try not equal to 0. Or equal to 0. So there is a second case. Oh, this is a mod. So it's a mod 4. That's kind of similar. The first time you see it, it's like, what? Let's try and, excuse me, not there. My guess is that that is, same thing. I'm going to keep the 0. I like the 0. And it doesn't change how this is being done. Almost there. I think I thought we were doing this load first, but it doesn't look like it. Oh, it looks like the positions are getting pulled first. Yeah, so that was just out of order. We have an odd number, an extra 5 in there. It could just be this. There's one symbol that's different, and that'll be a difference of 5. I just want to go through and make sure, but it looks like all the registers, not all the registers are fine. We'll have to figure that one out. So it looks like that's it. So right around 63. Yeah, not all the registers are fine. All right, so let me think about what's going on here. We're using register 8 is getting used as an implicit register. So in between here, oh, and this should be easy to work out. In between, we need a temporary place to store data that's part of this computation. So the rtan call, where's that? That result gets stored on a temporary register, and that's actually going to get stored, I think, in this velocity register. And then we're going to do velocity plus equals rand, and that was it. And does that fix all the other ones? I think so. So basically, we're just forcing MetroWorks. So this overlays for the PSP version are not optimized, compiled by MetroWorks, and so you get used to some of the quirks. If you're using one of these lower register S registers, you know that it's you have a high confidence that it's being assigned to a variable. S registers are registers that are meant for variables in the MIPS ABI. And that's what MetroWorks does. And so if you see a move into that register, so V0 is the return value, and it's being moved into S3, that tells me the return value of this rtan function is getting assigned to some variable, and ultimately that variable is going to be assigned to register S3. When I did all of that in line, no register or no variable is involved in that intermediate result. And so MetroWorks just chooses one, and it looks through all the registers that are being used and says what register is available. In this case, S8 was available, and so it just chose one. It might use that later for a variable, it might not. Yeah, but in this case, it wasn't being used, so that's what it chose. That also tells us what it might be. And we still have issues. So we're not out of the woods yet. The negation down here, oddly enough, may be related to these registers. There's some comparison or something else, likely unrelated, that's causing the V1 register to seem reserved to GCC. And so we have to figure out what that is. And we should be able to do that. It may be related to this add U down here on line 59. How about this? Fix that bug? Oh, not a bug. So there's something else. This should be a +1. How about that? And that was it. So I had a minus when it should have been a plus. And that fixes all the registers up there, and we're done. Easy. Even a caveman could do it. I think all those are gone. I think I've used the rest of these. The PSP is pretty good about having accurate stack space. So I don't think I need any of those. We gotta fix my math, so we got a 90 there. Maybe now it works with UV pair. No, it's not going to work with UV pair because of the +1 in here. Maybe you might be onto something. It would be prettier. Let's try it. I don't think it's going to work, and I'll tell you why. I don't think it's going to work because the way that this math is done, where we're multiplying params by 2 and then adding 1, that has to happen first. And what the PSP is going to do, if this is a UV pair, it's going to calculate the address of the UV pair and then add 2 to get the address of, sorry. It's going to calculate the address, then add 1 to that address. Whereas this is saying calculate an offset and then add that to this address. That's what I think is going to happen. We'll try it. We'll see. I would like it too. I don't think it's going to happen though. So here we're going to do .u. And then down here we get rid of the ×2 because pointer arithmetic will do that for us. And here we'll do a .y. And we should have a -90 if this works out to be the same thing. By y, I mean v, of course. And down here, we need to do the same thing. .u. And .v. Let's see, let's cross our fingers. No. This happens a lot in this code. So the first one's fine because the offset is 0. And so we don't have to add anything. But then our add here is happening in the wrong order, which is a bummer. We have our offset here. Our offset is 1 instead of being 0. So I would have liked it the other way as well. It happens a lot, though, in this code base. And so I'm just kind of used to it at this point. If this was going through a modern code review, would it make it? Probably not, but we don't have... We're dealing with old code. So let's get this integrated. Source boss B06 is Richter. We're in US 31944, I think. FE8. Gonna paste this in. We can't just compile now because we're missing the entity extension. So we're going to go include entity. Look for our union. Don't like velocity angle, but I'm going to keep it until I clean this up. Unfortunately, the way we have headers set up, this is going to recompile everything. Would it be better to undo this? Yes, it would be. So we're going to recompile. This will, yeah, about 1,200 files that all include this header. I'd like to get this split out, but entities used basically everywhere, so it'd be hard to optimize it too much. We could optimize it a little. So this should work. I didn't do anything drastic. And then we'll go with this one and see if that works. And that worked as well. So we have the orb. And we'll make a comment for myself here. We got Shaft's orb. Oh, static terminal. Oh, I'm going to undo everything that I did. So, to me, this is kind of the fun part. Thank you for telling me that I needed to reload terminal. Apologize. All right, so we have our file. We're eventually going to get rid of this include ASM. We have to add our entity extension in first. So I'm going to put the shaft orb struct in there, and then add the shaft orb struct to the ext union. And now you get to watch me compile all 1,234 files. Unfortunately, we can't add another file because then it would be 1, 2, 3, 5. And that's not as nice of a number. Or I need to refactor things to keep it some easy to remember number. Or, you know, not. And then we're going to paste in our stuff. And we're going to build. And it works. So here's our BO6 building. To show that I'm not just faking it. If I make a change there, it fails to build. So we did it. We did it. Oh, the terminal's still... What? It's working now. Yeah, it's working now. Yeah. We shall not count to 4. So that's it for today. We have, I think we have everything around Shaft done now. It probably would be good to go do the cutscene. Everything else, maybe I'll stop doing Richter on stream because everything else is basically Richter the player, and we have all that code already. You can go see all that. It's just going to be mapping code, and we did a lot of that with Doppelganger. Go watch March through June, and you can see all of that for Doppelganger. We're decompiling Castlevania Symphony of the Night. Like I said, I think we're about 40% of the way done, maybe a little further. I haven't looked at stage overlays except for top and RTOP lately. Those are both very simple. They have 4 rooms, not a lot of enemies, not a lot of unique things. So those went really fast. It was like 2 weeks to get those done. 2 overlays in 2 weeks is pretty bonkers. We haven't done a lot of the reverse castle stuff. And so I think that will be possibly next. And I'll probably take what I was doing originally was kind of going in order of how you'd get through the castle. And so we got through Outer Wall, and one of the next places you can go after Outer Wall is Castle Keep. And to me, it made sense to do Reverse Keep while you were there, because most of that was the same, and we could get both of those done at the same time. And then I did Richter because I was within that Castle Keep, even though in logic in the game, you wouldn't be there yet. But there's been other stuff that others have worked on. Clock Tower hasn't been worked on too much, or at all. I do want to circle back with some of the other people decompiling. I kind of, it was suggested several months ago that maybe we import everything, and then everything's free for anybody to work on. And I can do the import pretty quick. It probably takes me an hour or two to get a new overlay imported with all of the code deduped. Project Oblivion might have an even faster way of doing it. Full build takes around 36 seconds on my machine. That's the main reason I've been hesitant to do it, because it will take longer to build. Probably would go up to around a minute, I'm gonna guess. But is that worth it to get a better sense of how much is left? Possibly. I do know as well about a third of our compile time is splat related. And so maybe fixing that would keep our compiles down to around 45 seconds or so. I don't know. But that's where we are. That's a status update for the Symphony of the Night decompilation project. I just decompile things. Cyanamo started this several years ago, and hopefully I'm being an asset rather than a hindrance. But you can go to soten.z.dev to learn more, join us in Discord, see what we've decompiled, and have fun. Stop by, chat, like, subscribe, do all the things. And I'll be back tomorrow. Adios. Completely disagree. Eldritch, you've always been a scholar and a gentleman. Always appreciate when you show up, as well as all of you guys from the speedrunning rando community. Appreciate everything that you guys have done. Adios.